All right. On the warm-up, number 1, part A, Julian planted his garden in 4 rectangular raised planting beds. So he's got 4 planting beds total. The length of these planting beds is 6 feet, the width is 3 feet, and the height is 1 foot. If soil is sold in, we're doing cubic feet, how many should he order to fill all of the beds? If you're wanting to fill the inside, is that volume or surface area? That's volume. So volume is equal to area of the base times the height of the prism. What shape is the base? A rectangle. It said it was rectangular. And how do you find the area of a rectangle? Close. Length times width, or base times height. But they referred to length, width, and height here, so I'm going to use length and width. Times the height of the prism, or the height of these rectangular planting beds. So my length is 6, my width is 3, and my height is what? 1. Height is 1. So that gives me a volume of 18 feet cubed, but that is for just 1 planting bed.
Oh, you gotta multiply it by 4.
Yes. So we're going to take that 18 feet cubed. We're going to multiply that by 4 planting beds. And you're right, we get 72 feet cubed. So 72 cubic feet of soil is needed. Second part of this question, part B, says we want to know how much wood did Julia need to construct these planting beds? Does the wood fill the inside? No. That's what makes up the outside of these planting beds. So are we looking for surface area or volume here? Surface area. To find surface area of a rectangular prism, we do 2 times the area of the base plus the perimeter of the base times the height of the prism. But I want to think about this for just a second. Oh, I'm drawing this wrong. All right, so here's my little planting bed. We have 6 feet long by 3 feet wide by 1 foot high. What is a planting bed for? Plants, right? If you want plants in your planting bed, are you going to cover the top of it with wood? No. Otherwise, there's nowhere for the plants to go. You've trapped them in there. They won't get any sun. It also tells us down here at the bottom in parentheses, the bottom of the planters are placed directly on the soil. So would the bottom of this planting bed be made out of wood? No. So the only thing that's made out of wood are the 4 sides of the planting bed. So we don't need the area of the bases because there's no top and there's no bottom. So the wood that he needs to construct this, he's basically making like a hollow box. No bottom, no top, just the outline of a rectangle here. Yep, so we need perimeter times the height of these planter beds. Well, the perimeter, I have 2 sides that are 3 feet each, and I have 2 sides that are 6 feet each. So what would the perimeter be then?
2, 3,
How many?
7,
Not for my perimeter.
20,
What is 2 times 3?
9,
6. And 2 times 6?
12.
12. So then I add those together. So my perimeter is 18 feet. So I'm going to substitute that into my surface area formula. So I have 18 feet for my perimeter. And the height of the prism is what? The height of the planter beds. 1 foot. So the surface area is 18 feet squared. But that's for how many planters? Only 1 planting bed. Yes. And we get 72 again. So 18 feet squared times 4 planters. And we get 72 square feet of wood. Nicely done. One of the things I definitely want to caution you about, it tends to show up more often when we're talking about surface area than when volume. Think very carefully when they're asking about covering the outside. If you're going to cover the whole outside, or if you have a situation like we did with the cake and the icing where there's one of the bases that we're not covering, or in this case where we don't want the top or the bottom, so we don't use either one of those bases. This one we only wanted that lateral surface area. All right, we are going to hop into your notes now, page 5. Last week we focused on prisms. Today and tomorrow we're going to talk about pyramids. We are not in Egypt, but pyramids are still important figures. So first thing I want to do is name the different parts of a pyramid. The point right up on the very top of the pyramid, that's called the vertex. The distance from that vertex straight down to the base, and it has to make a right angle with my base. So if I were to take like a needle and go straight down from the top all the way to the bottom, we call that the altitude. The altitude is the height of the pyramid. And it is perpendicular to the base. The base is the bottom of my pyramid. Is it possible for a pyramid to be on its side? Could I do that? Yeah. In that case, this would be my base. Yes. When Sydney gets back. A pyramid is named by the shape of its base. How many sides does the base in this pyramid have? How many sides? It has 1 side.
Oh, I thought you said.
We've got 1, 2, 3, 4, 5. So we have 5 sides. What do we call a figure with 5 sides? A pentagon. So this would be a pentagonal prism, or sorry, pyramid, not prism. So So it would be a pentagonal pyramid. What about this one that I have right here? What shape is that base?
Square.
Square. So this would be a square pyramid. These edges right here that touch the base, we call those base edges. All of the sides of a pyramid are triangles. We call these the lateral faces. So this guy right here would be a lateral face. And no matter what shape my base is, each lateral face is a triangle. And then this edge right here, connecting my two triangles together, two of my lateral faces. We call that a lateral edge. Thank you. If I go from the vertex down to a base edge, and it makes a right angle with my base edge, we call that the slant height. We abbreviate it with a cursive L. That is the slant height. And if you look over here at this other pyramid where I don't have so much writing going on, that's this line right here that the arrow is pointing to. It makes a right angle with my base edge. It goes right up to the vertex. So cursive L, that is slant height. This is the height of the triangular lateral face. So on my little square pyramid here that I've got, the slant height would start at the vertex. It's going to go down this sloped side that's a triangle, and it's going to make a right angle where it hits that base edge. So if I look at it just as a triangle, it's the height of that triangle. All right, and then very quickly, types of pyramids. We have a right pyramid, and then we have all the other pyramids, which we call oblique pyramids. An oblique pyramid literally just means it is not a right pyramid. In order to be a right pyramid, that means that the altitude meets the base. At the base's center. So this is an example right here of a right pyramid. If I were able to drill a hole straight down from the vertex until it hits the base, that hole would come out right in the middle of this square bottom if I went straight down. So far, so good? All right. I want to look at the middle of the page here. Right in the middle of the page, we have a right square pyramid. What does that word right tell me? We just wrote it down up above. What does it mean for it to be a right pyramid? Yes, the altitude meets the base at the center of the base. So looking at this diagram over here, from the vertex right to there, it makes a right angle where it hits the base, and it's hitting right at the center of the base. So this is my altitude. What does the square part tell me? Yep, that the base is a square. Yeah, and it's okay to like think of it as the bottom because most of the time they are like this, but I want you to be careful because if on the homework I show you a pyramid like this is still your base. It's just kind of a knocked over pyramid. How big are the sides of the base on this pyramid in the picture? 4 centimeters. So there's my base edges. And so if I were to draw a straight line from where my altitude hits the base over to the base edge, since the altitude is hitting my base right in the center, and I know that whole base edge is 4 centimeters, how far would it be from where the altitude hits the center over to the base edge?
Let's say it's 4, half over 4, so 2.
That's exactly right. Our base edges here are 4 centimeters. It's going to be half of that. So this would be 2 centimeters. My slant height would be this right here. How could I find the length of that slant height?
Oh,
Yes, look at the shape that we've created right here. The altitude makes a right angle where it hits the bottom. And so we can do Pythagorean theorem to find the slant height. All right, so let's talk about how to find the volume and how to find the surface area. Volume for a prism that we did last week, area of the base times the height. With a pyramid, I've cut some pieces off of a prism. So it's not going to be area of the base times the height, but it's still related to it. This is 1/3 times the area of the base times the height of the pyramid. And the height of the pyramid is the altitude. So if we know what shape our base is, and we know how to find that area, then the only other thing we need to know is how far is it from the tip of that pyramid straight down until it hits the base. So far, so good? All right, so now we just need a formula for surface area. Surface area is a little bit more complicated. With a prism, it was 2 times the area of the base plus perimeter of the base times the height. Do we have 2 bases on a pyramid? No. So I don't need 2b. I just need 1 base. 1 base. And then we've got a set of triangles. However many triangles I have is equal to the number of sides on my base. So I want you to look at these 2 figures here. One of them is a built pyramid, and the other one is like if I were able to peel the sides down and lay it out flat. So here's my base. Because this particular base has 4 sides, I have 4 little triangles here. These are my lateral faces. I need to get the area of all of those lateral faces. They're all triangles, so 1/2 P cursive L. What do you think the P stands for? Perimeter of the square. Yes, perimeter of my base. What's the cursive L? The slant height, which is the length or the height of my triangle. This right here would be my slant height. So we have area of the 1 base. And then the 1/2 P times cursive L. We call that the lateral area, LA. This is the area of all the little triangles. Lateral area means total area of all the lateral faces. So that's that 1/2 PL. P is the perimeter of my base. L is my slant height. We are going to do 1 example on the next page, and then we'll save the other examples for tomorrow. We have just enough time to do 1. So let's flip over to page 6. What kind of a pyramid do we have here on number 1? A right square pyramid. So the square part tells me that my base is a square. It says the base edges are 12. So this edge right here would be 12. Since it's a square, this edge over here would also be 12. This edge over here would also be 12, and so would the one in the back. And then it says we have a height of 8. That's my altitude. So going from the vertex straight down to my base and making a right angle where it hits my base. That's 8. How far would it be to go from where that altitude hits my base over to the base edge? 6. Half of my base edge. Here's my slant height, L. I don't know how big that is, but what shape is this? Right triangle. So I can find that slant height by doing a squared plus b squared equals c squared. A, my altitude, is 8 for my altitude, excuse me. B, which would be half my base length, is 6. And that's equal to my slant height, cursive L squared. 8 squared is 64. What's 6 squared? 36. What do I get when I add 64 and 36? 100. That's my slant height squared, so then I take a square root of both sides. That'll make my squared cancel out on the cursive L. What is the square root of 100? 10. So my slant height is 10. What would the perimeter of the base be?
12.
12 is one base edge. How many base edges do I have?
1.
I have 4 base edges and they are all 12. So 48 for my perimeter. All right, let's find volume and surface area. Volume is 1/3 the area of the base times the height of the pyramid, or the altitude.
This base is 48, right?
No, that's the perimeter of the base. What shape is the base? A square. How do you find the area of a square? Side squared. So I would have side squared times my height. How big is the side of this square? 12. So we're going to do 12 squared, which you're right is 144. What is the height or the altitude of this pyramid? 8. So now I need to grab my calculator. 1/3 times 12 squared times 8. 384. Did they give me any units? Nope. So I'm going to write units cubed. All right, surface area. Surface area is equal to the area of my base plus the perimeter of the base times the slant height. What shape is the base again? Square. How do we find the area of a square? Yep, we're going to square 12. Take my side and square it. Do you have to what? If you already know what it is squared, you can substitute it right in. Yes. So surface area is equal to 12 squared, or 144. What's the perimeter again? 48. And what did we say the slant height was? 10. Ooh, I forgot my 1/2 here, guys. 1/2 PL. I am so sorry. 1/2 perimeter times my slant height. Perimeter is 48. Slant height was 10. What is 1/2 times 48 times 10? 1/2 times 48 times 10. 240. And then we add the 144, that's the area of my base, plus 240, that's my lateral area. I get 384. Do you think it always turns out that my volume and surface area come out to be the same number? No, in fact, it very rarely happens. It happened by coincidence here, but usually my volume and my surface area are not the same number. Right. We'll save the last 2 examples for tomorrow. The homework that you guys picked up on your way in the door is due on Wednesday this week. Homework is due on Wednesday.